Hello everyone. In this video, we'll explore a notorious network attack known as ping of death. A ping of death is an attack that involves sending a malformed or oversized ICMP echo request or ping to a target system. This can cause crashes, reboots, or instability in the target system. This attack gained popularity in the mid-90s, primarily affecting older systems like Windows 95. The systems vulnerable to this attack included Windows 95, NT, 3.11, early versions of Linux, MS-DOS, and macOS 7. Let's compare a normal ping with a ping of death. A normal ping packet is typically 56 bytes in size. When a target system receives this packet, it processes the request and sends back an ICMP echo reply. In a ping of death attack, an attacker sends an oversized ICMP packet that exceeds the maximum size of 65,535 bytes. This packet is fragmented into smaller packets, which, when reassembled by the target system, exceed the buffer limit, leading to a crash or other instability. So we can notice that the mechanism of this attack goes through 4 steps. Now let's look at how ping of death attack works step by step. Step 1. The attacker sends an oversized ICMP packet. Then, this packet is fragmented into smaller packets to be transmitted over the network. After that, the target system receives these fragments and tries to reassemble them into the original oversized packet, and upon reassembly, the oversized packet exceeds the system's buffer capacity, causing a buffer overflow and resulting in a system crash or instability. Fortunately, there are ways to protect against a ping of death attack. First, ensure your systems are up to date with the latest security patches. Vendors often release updates to fix vulnerabilities like this. Second, use firewalls to filter out malformed packets. This prevents harmful packets from reaching your system. And third, employ intrusion detection systems to monitor network traffic for signs of malicious activity and block such traffic. To wrap up, I'll demonstrate a ping of death attack in a controlled environment. I'll perform this demo on a Windows 95 virtual machine, and I will use Kali Linux to carry out the attack. So here's my setup. As you can see, I have virtual Windows 95 and virtual Kali Linux. In Windows 95, I open the date and time properties to see the exact time that the attack happens. Let's first check the IP address of this machine. Let's check the IP address in Kali Linux to see if they belong to the same network. The ifconfig, as you can see, it's 192.168.1.101, so they belong to the same network. Let's take a look at the code. This program is designed to send custom ICMP packets, typically used for network diagnosis like ping, from a spoofed source IP address to a target IP address. The packets are fragmented, and the program sends multiple packets with different fragment offsets. These headers include necessary functions and structures for creating and manipulating sockets, IP and ICMP headers, default number tries for the number of tries, packet size is for the size of each packet. The program expects between 2 and 3 command line arguments, the target IP, the spoof source IP, and optionally the number of retries. It defines a buffer for the packet and pointers for IP and ICMP headers within that buffer. It also declares structures for address resolution, which is struct aider info. The program enters a loop to send the packet's number of retries times. It creates a raw socket with the function socket, which allows for custom IP headers. Set socket OPT with IP header incl Option tells the kernel that the program will provide the IP headers. Get IDR info is used to resolve both the target and the source IP addresses from the provided hostname or IP addresses. The resolved addresses are copied into the IP header structures. The program sets various fields in the IP header, such as version, header length, type of search, TTL, total length, ID, offset, and protocol. This IDR is set with the target IP address. The ICMP header is initialized for an echo request, ICMP echo. A loop sends multiple fragmented packets. The IP header's fragment offset field is set for each packet. Send to function sends each packet to the destination address. After sending the packets, the socket is closed and the program pauses briefly with US sleep before the next iteration of the outer loop. That's mainly what the code is about. And now let's go and perform our attack. We first check the connectivity between these two machines. Let's perform a ping or traceroute. I prefer traceroute to the target machine. You can see that it is reachable. Then we can go to the desktop. Where the malicious code is. And you can see this is the code file pod.code.c. Let's compile it, gcc pod.code.c, and name it pod. I've done that before, so here it is. To execute it, let's first run /pod and see how to use it. You can see that we need to do sudo, then /pod, then the target IP, which in this case is Windows 95 IP address, then the spoofed source IP. We don't want to use the same IP for some reasons, and then the number of tries. You can do as many tries as you want. And then when I do the password and hit enter, it should stop the clock here. Check the clock and it stopped. This means that the system crashes and we need to reboot again in order for it to work. And of course, if we reboot, everything is going to work normally. That's it for today's video. Thank you for watching.